Integration of trigonometric functions. In week 8 we looked at differentiating our trigonometric functions and we found these following results here. So when we differentiated sine of x, we got cosine of x. Differentiating cosine of x, we got negative sine of x. And differentiating tan of x, we got either 1 on cosine squared x or sec squared x. Now we're looking at integrating, which is our reverse. So now here, when we're going to be integrating sine of x dx, here we're going backwards from this result here. So from sine of x, we're going backwards to our cosine of x here. And our negative sign can be here or here, but so long as we have opposite signs on either side, plus our constant c. Where our cosine of x, we end up going backwards through here and we get sine of x plus our constant c. And our third one we look at here, our 1 on cosine squared x here, integrating we go backwards and get tan of x plus c. We can also look at this in the format here where we've got sine of ax plus b dx. We get minus 1 on a cosine of ax plus b plus our constant c. Here we look at cosine of integrating cosine of ax plus b. We get 1 on a sine of ax plus b plus our constant c. And same with our actual tan here. Our equations on our formula sheet are in this format here. We have d on dx of sine of u is equal to cosine of u du on dx. So this is the same thing that we're going through here. So here our du on dx gives us this 1 on a. So here we've got our cosine, so whether we put it on this side or on this side, which way we work through it, it's not important so long as we understand what we're doing with that. So here d on dx of cosine of u is equal to negative sine u du on dx. So we know that we need to have this du on dx on this side to integrate to end up back with our cosine of u. And our third formula here, tan of u, is sec squared u du on dx. So if we go through to our examples here, our first example, we're wanting to find our indefinite integral of the following function. So we have 5 cosine of x. So we're going to write it, we're integrating 5 cosine of x. So 5 is a constant, so we can take it out of here. So we can make it 5 multiplied by the integral of cosine of x. So if we write our formula as it appears on our formula sheet, here we have d on dx sine u is equal to cosine of u du on dx. So here our u is just equal to x. So du on dx is equal to 1. So we already have our cosine of u du on dx with our u is equal to x here. So from this we follow through. It's going to be 5 going backwards here multiplied by sine of u, which is x here, plus our constant c. So looking at our second example here, we have here sine of 4x. So write our formula in the same way it appears on our actual formula sheet here. So we have d on dx cosine of u is equal to minus sine of u du on dx here. When we go through this, well, our u is equal to 4x. du on dx is equal to 4. So we know, well, we need to have it here when we're wanting to write our formula out. We're wanting to integrate sine of 4x here. And to do this, we're going to end up here. We're going to have a minus involved here. At the end, we're going to get a minus. And here we're going to have a 4. So what we're really wanting is 4 sine of 4x here to give our du and our sine. And to get this 4, we're going to multiply it by a quarter out the front here and differentiate here, integrate here. So we're going to end up here. This will go back to our negative cosine of u. So it's a quarter multiplied by the negative cosine of u is 4x plus our constant c, or minus a quarter cosine of 4x plus our constant c. So for our next example, we'll write our formula out again to start with here. So here we got d on dx sine of u is equal to cosine of u du on dx. And this is the formula as it appears on our actual formula sheet. So we have here u is equal to 2x minus 3. So du on dx here will be equal to 2. So we could use our 1 on a out the front of our cosine of u and so on, but we don't really need to here. We know, well, we need that times that. So here to get this into this format, we want our integral of cosine of 2x minus 3. And we're wanting it to be, well, here our integral of 2 times cosine of 2x minus 3. To get to this point, we're going to be multiplying by a half. So then we're going to end up back here with our sine of u here, so it's going to be a half times the sine of u, sine of 2x minus 3, plus our constant c. So for our next example here, we can go through, we write our formula as it appears on our formula sheet to start with here. So we have d on dx of cosine of u is equal to negative sine of u du on dx here. So we start here, u is equal to 4x plus 3. Du on dx, therefore, is equal to 4. So we're wanting it here to be, well, we want sine u times this 4 here. And we've got here is our 2. So we start off here, we're going, okay, we're going to have to put a half out the front. So we'll start here, we've got 2 sine of 4x plus 3. And so to get this, we're going to have to do, well, 2 times 2 will give us our 4 sine of 4x plus 3. And here out the front, we're going to multiply by a half. So we have a half, our integral of 4 sine 4x plus 3. Here, dx, should be writing these in, here, and so we follow this through. It's going to be a half times our negative cosine of u, which is 4x plus 3, plus our constant c. So we follow this through, we get minus a half cosine of 4x plus 3 plus our constant c.